Okay, so we're looking at problem 5 from the exam. This problem involves calculation of several limits. So let's jump right in. The first one is the limit as x goes to infinity, x over natural log of x all squared. So one thing some people noticed is that x is a power function that dominates this log function that's in the denominator, and therefore this limit has to be infinity. So if you use that argument, you receive full credit. That's perfectly fine. You don't have to do any calculations. However, we can also verify this using L'Hopital's rule. So the form of this expression, if we let x go to infinity, both x and log of x squared tends to infinity. So we have an indeterminate form of infinity divided by infinity. We can apply L'Hopital's rule. So L'Hopital's rule says that we take the derivative of the function in the numerator and the function in the denominator. So the derivative of the numerator is equal to 1. The derivative of the denominator is 2 log of x. And then by the chain rule, we multiply by 1 over x. Now with some algebraic manipulations, we see that this is the same as limit as x goes to infinity of x divided by 2 log of x. And this is still an indeterminate form of infinity divided by infinity. So we use L'Hopital's rule again. And when we do this, we get limit as x goes to infinity of 1 divided by 2 times 1 over x. This is the same as the limit as x goes to infinity, x divided by 2. And we can see that this is just equal to infinity. The 1/2 doesn't matter as x goes to infinity. This thing in the numerator goes to infinity, so the entire thing goes to infinity. Okay, let's look at b. We have the limit as x approaches 0, sine of 2x divided by e to the x minus 1. So as x approaches 0, sine of 2x approaches 0 because sine of 0 is 0. And since e to the 0 is 1, the denominator also approaches 0. So this thing approaches 0 divided by 0, so it is an indeterminate form. We can apply L'Hopital's rule. Limit as x goes to 0 of sine of 2x over e to the x minus 1. We apply L'Hopital's rule, take the derivative of numerator and denominator. We'll get the limit as x goes to 0, 2 sine of x divided by, or 2 sine of 2x. Okay, I've really messed this up now, haven't I? It's the limit as x approaches 0. Derivative of sine is cosine, so we get a 2 outside from the chain rule, then a cosine of 2x divided by derivative of e to the x minus 1 is e to the x. Now as x goes to 0, cosine of 0 is just 1. E to the 0 is 1. So this is no longer indeterminate. We can just plug in 2 and get the limit is equal to 2. Okay, next part. We have the limit as x approaches 1 of x log of x over e to the x. So this function, if we take a look at this, when you plug in 1, log of 1 is equal to 0. X just becomes 1, so the numerator looks like 0. The denominator is just e. So this is actually not an indeterminate form. So the function is continuous at x equals 1. It's not an indeterminate form. So to find the limit, we just plug in x equals 1. And when we do that, we get that this is equal to 1 times log of 1 over e to the 1, which is equal to 0. Okay, so last problem was the trickiest one. We had the limit as x goes to 0 of cosine of x raised to the power 1 over x. So if x goes to 0, this exponent goes to infinity, cosine approaches 1. So that means that this looks like 1 to the infinity. That's an indeterminate form. But this doesn't look like something we can apply L'Hopital's rule to right away. So first we have to do a little trick. We let L equal the limit as x goes to 0, cosine of x to the 1 over x. And then notice that if we take the log of both sides, we'll get 1 over x log of cosine of x. And so now we have something that does look like L'Hopital's rule. Log of cosine of x approaches 0. The denominator x approaches 0, so we can apply L'Hopital's rule. So we get the limit as x goes to 0. Derivative of log of cosine of x gives us 1 over cosine from the derivative of the log function. Then by the chain rule, we have the derivative of cosine, which is a negative sign. Derivative of x is 1, so we get this. So if we simplify a little bit, it's the limit of negative sine of x over cosine of x. And this is equal to 0. So if log of L is equal to 0, L has to be equal to 1. So that's our answer.